A very good morning to all my dear students. I hope the audio is clear. Good morning all. I will be starting the session at 9:20. Just wait for 1 minute. Okay. Thank you Devanjan for responding that the audio is clear. So I will be starting. Please wait for Okay, so a very good morning to all my dear students. Today is the second day of the week 2 of my class. Okay, now yesterday also I have taken one class and we discussed regarding the radix complement, that is the r's complement, r minus 1's complement. We discussed 9's complement, 10's complement, then we discussed 1's complement, 2's complements. Okay, and apart from that I also discussed how to do the subtraction and the other things are there, right? So all of you have the videos in your Instagram, so you can view it, so you can, and the PPT that also I will be sharing by the end of the week. Okay, now so today I will be starting with some of the very basic thing, just like that the last day I discussed regarding how to solve the Boolean function. Okay, so I will be starting with the two previous slides that I have used. Okay, the two prerequisite slides, the formulas which are required to solve the Boolean function. So that two slides I have used yesterday also, that I will be using at the very first, so that we will be requiring this the set of formulas for sake of reference. Okay, this is the thing I discussed in the last class. The main thing I will be requiring this law, double inversion law. Okay, and the set of laws, basically De Morgan's law and this laws. Okay, these laws are there. Okay, I am just keeping the pointer on. Okay, so basically De Morgan's, I have kept it intentional because I will be using this one. Okay, this one as well as this law, please note it down, this will be used. Okay, now today's lecture I will be starting with one problem solution. Okay, and this problem was given in GATE examination, so don't get scared that ma'am is starting with a great GATE problem, but you can solve it. Let's solve it together. Okay, because I prefer to solve in the class only. Okay, so the problem in GATE, this type of problem that we used to get, like they will give one question and they will give, that is a multiple choice question will be there, you have to solve it quickly and you have to get the answers also. Okay, now can we just keep one pen and copy with you so that we can solve it while being in the class. Okay, now if this equation is like this, so the equation is x bar y bar, please have one pen and paper with you and please try to solve with me, right? Then we have this xy. So there are four options. If you are welcome, if you are solving this one and giving the answers, you are always welcome. Okay, so this is the problem Now I have to solve this one. Okay, so this type of problem will be there also in the theory examination. Okay, so try to solve this one. Now for this case, you see, if I take common from the first term and the third term, what you are going to get? What you are going to get? You just take common x bar from the first term and the third term. So you will be getting y bar. Is a easy problem, right? It's not too much difficult. But the time is very much important as far as the gate is concerned. So as Nilanjan sir has told you that if we do the problems, if we study as well as if we do the problems of gate, it will be simultaneously we will be doing the normal semester examination preparation as well as the gate examination preparation. Okay, that's 2 problems I have given, not too many problems I have given, only 2 problems I have given. Okay. And if you take just the second term here, it will be like xy. Okay, it will be like xy. I think all of you are doing, right? So please take this one and solve this. Okay, then I will be going to other section also. Now you see this one, if you take common this one, so what you are getting? Y bar plus y. So y bar plus y will be 1, right? We know this formula. The variable with its complement will be 1, right? So you have this x bar and you have xy, right? You have xy. Okay, now can we write this one? I am going to the formula part. Okay, I am going to the formula. You have seen one formula. Have you seen this formula? A plus a bar b equal to a plus a bar b. One formula is there. A plus a bar b equal to what? The formula is a plus b. Have you seen this formula? Please note it down. This formula is very, very important. We will be using this formula multiple times. Okay. So which one you are considering as a? Which one you are considering as a? Suppose x bar you are considering as a. Okay. So if you consider x1 as a, so we are writing it again x bar, and can we write x as x double bar? Can we write x as x double bar? So it will be x bar bar. So we can write it here, right? So we can write it. This will be like into y. So is it coming in this form? X bar is a. So a plus a bar into b. Okay. So what will be the answer? It will be a plus b. What is a here? A, I have considered this one as a. And what we have considered b? We have considered b as this one. Okay. So we have considered. So what will be the answer? I think it is visible, right? Last day it was not visible and you are just telling me that it is not. So I am just writing in the horizontal platform. So that this will be x bar plus the another thing x double bar I will be considering as a bar, right? X double bar is considering as. So it will be, I will write only y. Y is what? Y is b is, right? This is a and this is b, right? So we can write it down that a b will be the a plus b will be the answer for this. This is very easy. It's not like that you cannot do all these things in gate exam. You can do if you practice, if you remember the formula. Which formula I have taken, I am just going back to this. That's why I have given this one. You see, I am using this formula. Okay, I am using this formula. Okay, so this formula, De Morgan's law, and this one I will be using a plus ab equal to a plus b into a plus c. This will be, this also I will be using, right? Okay, this is done, right? Any doubt about this? If you have any doubt, please just tell me, then I will go to the next. Okay. Okay, go to the next problem. This problem, it is a bit lengthy, so we need to solve it one by one. Okay, it is not in the, yes, you are correct, it is not in the option, that is also correct, but we need to solve this one. Okay. Now, if you see this one, the second question I am just telling you, so there are comment portions also. Okay, you just tell x into y bar z bar plus yz. Can you tell me y bar z bar plus yz is what? It is basically the XNOR. No, you know this is basically y XNOR z is the thing. Okay. Anyways, now question is that you need to complement the function f. You need to complement the function. Okay. Now when you are going to do the complement of this, so what you have to do, you have to take a full bar over this, right? You have to take a full bar over this. Okay. Now when you are going to take a full bar over this, you will be using which law? De Morgan's law. So what we are going to have? So this you can take this term as something into, you take this one as the first term, this one you can take as the second term. Okay. Now what we are going to do here, we will be breaking the bar and putting the small bars over x bar and another bar over the full thing. Okay. So we can write it here as x bar, then dot will be converted into plus. Okay. And then we have this y bar z bar plus you have yz, this whole bar. Okay. Is it clear to you? I hope it is clear to you, right? Now when you are having like this, so what we are going to do next, you have to do again, you have to use the De Morgan's law over this. Okay. Now let's see what is going to happen here. So we can use this. Now here what we can do, this you can take as one term, this you can take as another term, like a plus b whole bar. So what we will do, this whole thing bar dot this whole thing bar, right? So we will be using like, so we can do it like y bar z bar, we can take it y bar z bar whole bar dot, or we can write in a bracket for our ease, and we can take yz and we can take this one as common and in a bracket, and this, can we write this? Now so the handwriting is not so good, so I am doing the y bar into z bar plus has been converted into dot and this yz whole bar. Now what we are going to get here, it will be x bar plus this is what, y bar, the bar will be broken, then it will be y double bar, right? Y double bar will be there plus z double bar will be there. Okay. So I can take another bracket for sake of use, and this will be one thing, another, this one, this will be y bar plus you have z bar. We can write it here also. Now if you do it, I am just closing this bracket. Okay. Now if you multiply this one, this will be what? If you are doing this y double bar, what we are going to get? Y you are going to get. So I can write it here also, that it will be x bar. I am writing it slowly because the handwriting will be distorted if I try to write it first. So it will be simply y double bar is y plus z will be multiplied with y bar plus z bar, right? Yes, I am getting the answers. Up to this it is clear? I hope up to this it is clear, right? Now if you do this one, what you are supposed to get? What you are supposed to get, you have to multiply y with y bar, that will give you what? So I am writing x bar first, then y, this will be plus, then y into y bar will give you 0, as well as z into z bar will also give you 0, right? So what is the two other product terms that you will be having? You will be having y bar, sorry, this one not bar, y into z bar, So y, so this is not bar, okay, I'm just erasing that, I have just pointed out this one, okay. This is not the bar, this will be, okay. So y into z bar will be there, okay, plus y bar into z will be there, right? I think it is visible, okay. Now if you do like this, you will be getting which option you will be getting? Which option you will be getting? You will be getting like x bar plus yz bar or y bar z plus yz bar, okay. So you will be getting this option, right? So this will be x bar yz bar plus y bar z, okay, this one. I hope it is clear, right? I hope it is clear, right? Yes, correct. Correct. Please give your name so that I can mention your name also when you are typing. So, yes, B is correct. Shudeshna Bhomik, it is correct. Yes. Yes, many of you who are doing is correct, okay. So we can solve this one, like, so this type of gate problems also you can do it. These two are basically two gate problems which we solved, and it will be there in the video, you can just check it if you require, okay. Now let's solve another thing, how to realize a function using NAND gate, okay. There will be two methods, okay. Normally in first year we have used this one, but still in questions we will be giving this type of questions also, okay, in the final semester examination, okay. Now for this case, let's see this one. Yes, Orijit also you are correct, okay. Orijit, you are also correct, very good. I got it from you first, okay. Now how will you do it? Like you take a function like this, okay. What is the function I have taken? Same function I have taken here, AC plus BC bar, okay. This is the function I have taken. Now if you use normal, it's not NAND implementation, the first slide is for the simple basic gate implementation, okay. Now in case of in the last class, actually some of your friends told me that the speed is a bit faster, okay. You people are unable to understand the 2's complement method and the subtraction. Few answers I have given, but some of the answers I have not given due to the time crisis, so I will give answers by the end of the day today, okay. Those queries I have not answered, I will give the answer by today, okay. Okay, so this is the function. Suppose you have a function like this, and I am implementing the function using the AOI. AOI is what? AND OR inverter. So simply using basic gate I have implemented this circuit diagram, okay. This is a fundamental. But my requirement is what? My requirement is to implement the same circuit using NAND gate, okay. My requirement is to implement the same circuit using NAND gate. Now why it is required? Because you see, for this you require one IC of 4069 as per the experimental point of view. For this you can get the two AND gate in one IC package 4081, and for this you have to use 4071. So you have to purchase 3 ICs, right? Whereas if you use one NAND gate IC, that is 4011, you will able to maybe 1 or 2 NAND gate, it will be easier for you to implement that one, okay. So cost will be lesser, okay. Now let's see how we can do it. Now you know in the practical that this NAND gate, this NOT gate can be implemented if you are using NAND, or nor maybe the NOT gate, I am doing it slowly, okay. The NOT gate you are implementing as shorted NAND. I told you in the practical that this NOT can be implemented as the shorted NAND, okay. Similarly, if you see the AND gate, how you have implemented the AND gate, you have done like this way. You have taken the input AB through two of the inputs of the AND gate, like NAND gate, and then the output you have passed through the shorted NAND gate, right? And you obtain the output like AB. This is the way you created. If you do not remember, this is the circuit diagram we used for sake of just brush up. Okay, now if I replace this NOT gate using this one, and I replace each of the two AND gate, I am repeating once again, if I replace this NOT gate using this shorted NAND, and if I replace this AND gate, each of the AND gate with this circuit diagram, okay, and OR gate you are having a big circuit diagram, it is in your copy only, okay, we have done in the practical, okay. So if you replace all these things with this type of NAND gate, you will be having a equivalent NAND implementation of the same circuit. Let's see in the next slide what happens. Now see this one. In this circuit diagram you can see I have replaced this NOT gate using the shorted NAND gate. I have replaced this AND gate within this diagram. In the previous slide also I have shown this diagram, right? So this diagram was the equivalent AND diagram of using NAND, okay? And both the AND gates will be, so for this AND gate I will be using this diagram here. For this AND gate also I will be using this diagram here, okay? And for OR gate I will be using this diagram. Is it clear to you? If it is not, please tell me. So till I have not yet received any message, so it is expected that you have understood, okay. So next slide will be presented in form of replacement of this basic gates using the NAND gates, okay. Let's see the next slide. You see I have replaced this one, right, using the NOT is replaced by the shorted NAND. If you see it carefully, this is the AND is replaced by this form of representation, that is the, then again the second AND is also replaced by this, and if you see this one carefully, this is the replacement of the OR gate, right? So this is the replacement of the OR gate, okay. Now you can tell me, ma'am, in one IC package how many NAND gates are there? 4 NAND gates. So you will be requiring the same 1, 2, 3, 4, 5, 6, 7. So how many NAND gates will be required? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you will be requiring suppose 8 means 2 ICs are required. Can we even reduce it? Can we even reduce it? Okay, so let's see. I am just removing this, erasing this link option, okay. Now you check carefully. This is one NOT gate. If you just remove, forget about what is there. So if you just see this one, if this point is X, what is the output at sectional point? This will be shorted NAND, means X bar, okay. Then again this X bar is again going to another NOT. So this will be X bar. So this is what? X. So if you have two NOT gates simultaneously, one after another, then what will happen? Then actually you are ultimately whatever X is there, you are going to give it right here, right? So there is no meaning of giving two NOT gates simultaneously. We can omit the two. But if it is one NOT gate, we cannot omit it. So if simultaneously two NOT gates are there, we can omit it, okay. Similarly, if you see here, this is one NOT gate and this is also another NOT gate, okay. So X, suppose it is Y, so Y, this will be Y bar and this will again be Y double bar. So can we consider Y double bar is again Y, right? So is there any requirement of two NAND gates? Sorry, two NOT gates. Shorted NAND mean not, right? So we do not read. So we can, whatever we are getting here, we are also getting here, same Y. So we can omit this two. Is it understandable? Please ping me and let me know, is it understandable? So if it happens like this, okay, which one you are going to tell to repeat this? What I am telling here, just please see this one. After this it is clear, right? So NOT gate is replaced by shorted NAND. The way I have done in practical, the NOT gate is replaced by shorted NAND. The AND gate is replaced by this circuit, each of the AND gate. This AND gate is replaced by this one, as well as this AND gate is replaced by this one. And lastly, the OR gate is replaced by this one. Okay. Now, if you just replace it, what you are supposed to get, I am removing this one once again. Just so I have replaced this NOT with, see, the previously this NOT is going to be replaced. So we are getting this AND is going to be replaced by this. So here we are getting this, and this again, this second AND is also going to be replaced by the same circuit. Okay. So we are getting again this. Okay. And if you see this one, the OR is going to be replaced by this type of circuit. So if you see this way, you will get this OR is the equivalent NAND based equivalent OR circuit. Okay. Now what I told you in the last presentation, if you are having this is NOT, again NOT of NOT is whatever is this output, that is ultimately going to this output, right? NOT of NOT means what? The same thing. If you have X at this juncture, you will be getting X bar at this juncture, and you will be getting X double bar at this juncture, because it's a NOT operation. Shorted NAND is working as NOT. Okay. So if you are finding, I hope it is clear, right? It is clear, right? Okay. So what I have done in the next slide, I have done in this way, I have omitted this 2. So what is going to happen if I just put a wire from this to this, it will be replaced by this, and you are just putting a wire from this to this. I will replace this 2. Okay, and this 2 and this 2 also. Okay. Now what we were going to, you see, just simple, those two, the upper 2 NAND gate and the lower 2 NAND gate has been vanished. I do not require it, right? Because what is the meaning of, if we are getting the same X after 2 NAND NOT gate also, we are getting the same thing. So ultimately, how many NAND gates you are requiring? You are requiring basically 4 NAND gates, and 4 NAND gates means how many IC? In one IC actually. So in the AOI model, how many ICs you required? You required basically, I am going to the previous one. How many ICs you require? For this you required 1 IC, for this too you required 1 IC, and for this one you required 1 IC. So you required 3 ICs. Whereas in case of NAND representation, you have reduced, moreover not only NAND, you have reduced it also. You obtained the same thing using only a single IC. Only a single, which IC? NAND IC. Okay. And what is the IC number of this? The IC number is 4011, right? I hope it is clear to you, right? Okay. Now if you want to validate this one, so how you can validate? You can just tell me, ma'am, whether it is happening like this. You can see it here itself. If you are giving C at this point and it is shorted NAND, what you are going to get? You are going to get C bar, right? You are going to get C bar. And if this B you are tapping from here, and you will be getting that B into C bar. So you are getting B here. So B into C bar whole bar at this point you are getting. Okay. Similarly here you are tapping at this point from C. So at this point you are giving C, and here you are getting A, right? So you are getting A into C bar. Okay. This two you are getting, and at the output you will be getting this one as B into C bar whole bar into A into C bar whole bar, and this output will be like Z. Okay. I hope it is clear to you, right? I hope it is clear to you. AOI model is, we are writing in short. Actually AOI means AND or inverter using basic gates. Okay, somebody asked me what is AOI model. Here I have used, please write it down. AOI means AND or inverter. Okay, you can see AOI stands for AND or inverter. Okay, is it clear to you? Okay, so this is the comparative study. What I told you, required 3 ICs if you are going for AOI model. If you are going for NAND implementation, you will be requiring only a single IC. So it will be better for you to use this NAND based circuits. Okay, now this is very important. Okay, so all the rules apart from the first 2 slides, I have shown you all the rules, right? How to do the Boolean operation and all these things. Now this is very important as far as the exam is concerned. Please note it down in your copy quickly. The consensus theorem. Okay, just see one by one. This theorem is basically shows SOP and POS is the sum of product, and this POS is the product of sum. Okay, in the lab I told you, today also I will be telling all these things. Okay, now this thing, consensus theorem will be applicable when there are 3 variables. You can see there are 3 variables A, B and C in this left hand side of the expression. Okay, and each variable is used 2 times. That means A has been used 2 times, C 2 times and B 2 times. Okay, left hand side I am concentrating. Third point, the first 2 points are done. Now what is the third point? It shows only one variable out of the 3 variable, only one variable. Please note it down. Only one variable will be in the complemented or in the non-complemented form. So can you see which variable is the in the complemented? So you can see the B out of 3 variable. If only one variable, here in case of B, it may be in case of C also. So it happens, if it is happening in case of one variable, that it exists in the true form as well as in the complementary form, then we can reduce this one, then we can reduce this expression as this. Okay, there is proof also, so I will be doing the proof. So please note this formula quickly so that I can do the proof also. Okay, I can do the proof also. Okay, so I will be doing the proof of POS. Here also you can see there are 3 variables. Why it is SOP form? SOP form, this is one product. Okay, I am just removing the erasing all. Is it clear to you? Okay, so why it is SOP? This is the sum of, this is a one product term, this is another product term, this is another product term. Okay, so and you are doing the sum operation over individual product term, so you are getting the SOP, sum of products. Okay, whereas in case of POS, product of sum, so you should actually read from the right hand. Product, you just take 3 products are there and then you are doing the sum, and here sum you have, the sums you have, and you are doing the, so from right you try to read it. Okay, you have the sum and then you are doing the product of all the sums. So for this case also, let's prove this one. Okay, let's prove this one. Please note it down and I will be proving this one, because the proofs will be there in the exam. Okay, so the proofs will be there in the exam. Let's try to prove it one by one. And to prove this one, actually we will be requiring all the previous theorems, okay, which you have studied. Let's see. Okay, so what is the expression I need to prove? I am just writing one by one. Please be slow and try to prove it. Let's see what happens. You have this A plus B, this is one, the POS term I am going to prove. You can, your assignment is, you can also prove the SOP term. Okay, you have this B bar plus C, this is a second term, and the third term is basically a plus c. Okay, you have this a plus c. Okay, now what is the output we are getting? As far as the consensus theorem is concerned, you will be getting a plus b, a plus b. We have to prove it. Okay, we have to prove this one. It's the left hand side, and here we have to prove the right hand side. Okay, so a plus b, and we multiplied with b bar plus c. Let's see how it is happening. Okay, I'm writing it slowly so that it will be easier for you to understand. Now when you are doing this one, so we will be doing this one as a plus b. We can do it a plus b. Then you have this b bar plus c. Now I will take the third term like AC. Now in the third term, which parameter is missing? The parameter which is missing, that is b, right? So what we can write, that can we write in this fashion, a plus c plus b in 0? Can we write it down here? We can write it here, right? So we can, something plus 0 will be some, that's the same thing, right? Now what I am doing here, I am writing the first two terms as it is, a plus b, and you have this b bar plus c. Okay, and I am replacing this 0 by what is the missing term? The missing term is basically b into b bar. So what I am doing now, I am just proving the consensus theorem. In the last slide you have seen the POS term and the SOP term. The second one I am going to prove it. Okay, now in this case I am replacing this with b into b bar. So we have to write a plus c, and the 0 is basically replaced by b into b bar. Okay, b into b bar, I will be replacing the 0. Okay, now if I just now you see this one. Okay, I'm just keeping this 2 as it is, a plus b, and the second term is also b bar plus c. Now what I am doing here, just see this one formula. If you remember one formula, if you have x plus yz, suppose, is a formula, can we write it down as x plus y? With this formula I am going to use this formula. Okay, x plus y into x plus z. Can we write it down? Because I have one formula here. This is one formula, that if you have this x plus y into z, we can write it down, we can break it as x plus y into x plus z. Okay, into x plus z. Now if you see this one, consider this one as x. Okay, consider this one a plus c as x. So if you consider a plus c as x, and if you consider the second one, that is b into b bar as y into, so you can consider this is as x and this is as y into z. So how can you break this one? Can we do it slowly? A plus c, that is x plus y will be there, right? This is x will be a plus c, and y is, suppose, b. Okay, so a plus c plus b will be there, that will be one term, and the second term will be what? A plus c, that is x is a plus c. I am taking, because this is constant, right? A plus c, this is x, right? And this is b, y, and this is z. So a plus c plus b bar will be there. Can we write it here? We can write it here, right? Now for this case, if you see, now you have the term, right? So if you take common, if you just take the first term and the, you can say the first term and the third term, if you see, we can write it as a plus b plus c also, right? I can write it as a plus b plus c also. Can we write it? Do it slowly. A plus b, this first term I am writing a plus b. Okay. Now the second thing is that this term I want, so I am just rearranging this one as a plus b plus c. Okay, a plus b plus c. Is it visible? I think it is visible. Now this two term I am keeping the first and the third one, and the second and the fourth I will be keeping together. That is b bar plus c. I am just writing it here, b bar plus c. And this one I am just rearranging this one as b bar plus c plus a. Can we write it in this fashion? Just I am rearranging the fourth term, b bar. It is written a plus c plus b bar. I am rearranging b bar plus c plus a. Okay. Now let's see. You take this term, this two and this two. Another formula I have, if you have like x plus xy, can we write it as x? Because you can take common x, 1 plus y, it will be x, right? X plus xy, can we write x? Because you can take common x, it will be 1 plus y, and 1 plus y will become 1, right? So it will be x. So can we apply this one here? So you can take this one as x, this will be x plus y, right? Can we apply it? So this is suppose x and this is suppose x plus y. So for the first two term, okay, so plus sign will be there, I missed it. Okay, now sorry, this one will be there. Okay, now another formula is also there. Okay, another formula is also there. Now can we replace this one? Can we replace this one? So if you have this x into, so can we replace this? So if you, I am just removing this pointer. Okay, so just wait. It's become too much clumsy. Okay. This is not plus, this is into. Okay. Okay, so if you take common a plus b, it will become like a plus b, right? So if you take common a plus b, it will become a plus b. Proof of SOP, please do it. If you are unable to do, then I will do it again. Okay, and from this two term, can we take b bar c as common? Can we take b bar c as common? This one is b bar c again, so this is x, so this is, you can see, you can take common b bar c and you can just 1 plus a will be there, so you can write down b bar c is there. Okay, so this will be product, so you can prove it here, right? So this is the way you can prove it. This is the consensus theorem. Okay, now this is a proof also, you can do it by yourself, but this is not perfect as per my knowledge. Okay, now can we realize a function using NAND gate? The way I have shown you to removing the AOI to NAND, that is AOI to normal NAND, that the way we have done, another formula is there. Another formula means in the first year you have done in this way actually. The way is what? Suppose you have a function like this. So if you have a function like this, can we just replace this function? Thus we have a function f. Can we write it like f double bar? that we can write it like. So the question is, implement this function using NAND gate. Please write down the question. Implement the function using NAND gate, and then you have to draw the corresponding circuit diagram. Okay, so if it is like that, so suppose if a b c d is the function, so we can write it here like a b plus c d. I am keeping it this one, and I am doing it double bar, right? Can we do it double bar of this? Because this is a function, I am doing the double inversion. Now you apply De Morgan's law. Which bar I am interested to break? Which bar? The lower bar, right? The lower one. The upper one you keep it intact. Okay. So the upper bar you are keeping intact, but the lower bar you will be doing a dot b whole bar, okay, dot c dot d bar, right? So this one will be one. So you can see this you can implement using one NAND gate, this you can implement using another NAND gate, and this, if you see this as x and y, the x and y dot, this thing will be you can implement using the third NAND gate. So what will be the circuit diagram for this? Can we just draw the circuit diagram for this? I am erasing this too. Okay. So you just take this one, you implement this through one NAND gate. So this will be AB as the input you can take. Okay. So if you are applying this one, this, so you can, so it will be A dot B bar. Okay. A dot B bar will be the output. Okay. And then if you are implementing another this one, how you can implement? You take another NAND gate. You take another NAND gate CD and you use the output. Now these two output will pass through the third NAND gate, okay, because if you take this one as a whole and this one as a whole, this will be you are using a product in between these two and then whole bar. So this two term, this will be C dot D bar, right? C dot D bar. Okay, so you are doing this as the output, you are sending this A dot B bar and C dot D bar as the input of the NAND gate, and you are sending the output as the final output, right? I am not writing it again. Okay, so what you are supposed to get? You are supposed to get what? You are supposed to get this expression. Is it clear? Is it clear to you? Okay, so hope it is clear to you. I have not seen which part is not clear. Can you please tell me? Okay, I am repeating, this NAND part is not clear. Okay, let's see the questions. Answer is not there. Ma'am, there will be number of plus between A plus B and I have changed that one. Okay, I have changed that one. Plus will be replaced by dot as per which law we are using? De Morgan's law we are using, right? De Morgan's law we are using, right? So you have not studied the last class. I think we have used the De Morgan's law. That's why we are replacing, we are breaking the bar and we are replacing the plus with dot. That is the rule of De Morgan's law, right? The NAND part I am just repeating once again. If you are given with a function, I am just removing this with the eraser. Okay, so the question many of you have not understood. Just wait 1 minute. I am just telling you. Okay, if you are given with a function, the function can be written as f double bar, right? So if you are doing this, this will be the f double bar. Okay, so f double bar is you can break it into two part. So if you have any further query, please send me which part. Otherwise, previous one is, many things are previous, right? So you have to be very specific. Okay, otherwise I am not understanding which part you have the confusion. Okay, So NAND part, is it clear to you or not? So this you are breaking this bar, the first bar you are getting a dot b bar, and you, as per the De Morgan's law, you are doing this and you are getting this dot instead of plus, and you will be getting this. Okay, so and from the circuit diagram point of view, you are taking this a dot b, you are implementing this one through the proof part. Okay, proof part is easy, right? Proof part is not so difficult. Which part you are not feeling comfortable? Please, I will let you know the class is done, right? I think it is clear to the thing we have done, it is clear to you. We have inserted 0 here, inserted 0 here, then 0 is replaced by b into b bar. Okay, b into b bar, because 0 will be replaced by the term which is not there. Okay, so which term is not there? B is not there. That's why I am replacing the 0 with the missing term. Okay, consensus theorem I am just telling. Okay, many of you are having doubt, I am telling one by one. What I have done here, this proof is the same thing, but they have not done properly. That means I have done the a plus c into b bar, but this is difficult to understand, that's why I have done in this way. So the missing term is b into b bar, so b is the missing term, so I am replacing the 0, because we know that the variable into bar of that variable will give you 0. Is it clear to you? I think so. Next, what I have done, you have this variation, that is a formula is there, x plus y into z. So which formula I am talking about? Please try to recapitulate the previous formulas also. Okay, see, I have ticked out this term. A plus bc, you can break it into a plus b into a plus b. This formula I am writing in terms of x plus y into z. This way I am writing here. Okay, so because I have used ac, that's why I am not. So x plus y into z will be x plus y into x plus z. So what I have done, so you can consider this one as x, this you can consider as y, and this you can consider as z. So what I am doing, so x is what? X is a plus c, x plus y is b, okay, and then x plus z, right? X is a plus c and z is b bar. So this is the way we are writing. Okay, so I think this is done, this part is done, okay, due to this formula. Is it clear to you? I hope it is clear to you, right? Now next part, so how many terms we have? We have next line, we have 4 terms. We have taken the first term and the third term. So first term is what? A plus b, and this will be into, right? This is not plus. So this a plus b will be the first term within bracket, and then you have the second term a plus c plus b, but I have rearranged it in the a plus b plus c, because you have the law also, because using the law also you can write down that a plus b plus c. Okay, this the first and the third term I have kept aside, and the second term is b bar c, and the fourth term is a plus c plus b bar. So second term I have kept it as it is, whereas the fourth term I have just shuffled a little bit. So I have just put the b bar, then c, then a, right? Now if you have the term like a plus b, just I am erasing. If you have this problem, then I can erase this part. Okay, I am unable to do the SOP and POS. Maybe in the next class I will be doing. So can we write this one? Just wait. Okay, so from this part you have this a plus b, you have, I am rewriting this one, you have this a plus b, okay, and you have this a plus b plus c. The other part is same as it is. Okay, now from this, can you take common a plus b? You can take common in one line. I have written that if you take common a plus b, what will happen? 1 plus c will be there. So you can write it another bracket. So is it clear now? So 1 plus c is what? 1 plus c is 1, right? So if 1 plus c is 1, so what you are getting ultimately? You are getting ultimately a plus b, right? You are ultimately getting a plus b. I hope it is clear to you. So similarly, if you take the second and the fourth term, you will be getting what? You will be getting b bar plus c. I hope it is not understandable or not. So if you have still doubt, you can just tell me personally. Okay. Now hopefully this is the thing that we have done. Okay, the thing is there. I will remove it. Now next class I will try to cover the graphical transformation, because now the time is not there. But before that, I will just one example I am going to tell you. So lots of things are there. Graphical transformation is very, very important as far as the gate is concerned. Okay, they will give one circuit diagram and they will tell you how to solve it. Okay, in normal question also we can see the theory. Okay, now for this case, what is this is a simple AND gate, and in case of AND gate we can find that A into B, you will get A dot B. In case of A into B, you will get A dot B. We can replace this same AND gate using another form this way. Now I will give you a circuit where the normal AND gate will not be there. Now can you prove this way? So when a bubble is there before the input, you can say it's not A is going to be as the input, it will be A bar that is going to be as the input, because before this A line is passing through a bubble, means not gate. Okay. Similarly, if it's a OR operation, so if this is the second B is passing through another NOT gate, so the second input is B bar, it's not B. Okay, and it's a normal OR gate, that's why I have given plus, and then again a bubble is there, so it will be whole bar, right? Is it clear to you? Is it clear to you? I know it is not clear if many of the cases, but I will try to clarify as far as my so after the class you can just send me, and one by one it needs to be solved. Okay, because it's a multi type of people are there, so it is very difficult to understand who is understanding and who is not understanding. So please one by one clarification is required. Okay, I think it is clear, right? So when you are putting the symbol here, this A is passing through a NOT gate, that's why I have given A bar. Then the B is also passing through a NOT gate, we are giving B bar, and then we are putting plus because the symbol is OR, and then it is a whole bar because the NOT symbol is there. Okay, now can we resolve it using the De Morgan's law? So if the bar is broken, you will get what? You will get A double bar. Okay, A double bar will be there. Then instead of plus you have the dot, right? De Morgan you will be using dot, and then you have B double bar, right? So A double bar is what? A dot B double bar is B. So I think it is clear, right? So why, you can ask me then, ma'am, why you are telling this symbol is working as AND, right? This is the clarification, that if you are passing this, so if a circuit is like this, right? So if a circuit is like this, like if you have input like this 1 and B is 1, suppose A is this and B is this. Okay, so can you tell me what is the output? No bubble is there at the output. What is the output? Simple one bubble is there. So what is the output? It will be the Y is the output. So Y is supposed to be, what is the input? It's not A, it's the inversion of A, because the input bubble is there. So it will be A bar plus B is simple, so it will be simply B bar. Sorry, simply B. So this will be the function. So if you have a complicated function containing this type of symbol, I think you can solve it, right? Anyways, I'm just removing the erasing this one. Now for the second case, what will happen? Can you do it by yourself and tell me the answer whether this output is also giving a plus b or not, because it's a seems to be an AND gate, right? So what will be the first input here? It will be a bar because it's a bubble. B input is also, and the symbol is AND, right? So we are putting AND here. So the second input will be B bar because B is passing through a AND gate. So this input will be B bar, and this symbol is of an AND gate. Okay, so we are putting AND, then you have the bubble, so it will be whole bar. Okay, so if you see like this way, it will be like A bar bar, and you use the De Morgan's law, bar will be broken, so A double bar dot will become converted into plus and B will become B double bar. Okay, so A double bar is what? A, and you have this B double bar is B. So it is working as the OR gate, right? I hope it is clear to you. It is working as the OR gate. So this is the way we are doing the graphical transformation. In the next class I will be doing the graphical transformation for this. Okay, you can see for this the NOR gate is basically converted is this. Now your question for the next class will be how can you, so there will be the NAND gate, the output is NAND gate, what will be the equivalent? This is going to be your assignment. Okay, so it's already 10:20. I will not exaggerate too much. Thank you all. Thank you being in the class and listening all these things. The clarification I will do it for yesterday's class as well as today's class. That is my promise to all of you, and one by one. It's not at a time. Okay, so at a time it's difficult. One by one. Actually Thursday and the Friday schedules are very hectic, so it's I do not get time to reply you all. Okay, so thank you being with me. I am just opening the Google form. Okay, thank you. I am ending the stream. Okay.